This is part 2 of the 2.10 separating solutions. Petroleum is refined by fractionation. In its raw form, petroleum is a mixture of hydrocarbons and other compounds. Because it isn't very useful in this form, it needs to be refined through the process of fractionation at oil refineries. The animation shows the fractionation of petroleum. Crude oil, or unrefined petroleum, is placed into the tower and vaporized. As the vapor enters the tower at its base, the byproducts of crude oil rise and are condensed and collected. Propane and butane gas are the components of crude oil. These rise the highest in the tower and are collected near the top because they have the lowest boiling points. Gasoline has a low boiling point and will not condense until it gets near the top. Kerosene and jet fuels rise part of the way in the tower. Heating oil and diesel fuels are collected farther down, and lubricating oil has the highest boiling point of all. It condenses and is collected at the bottom, soon after it enters the tower. Alright, so we have fractionation, and I'll turn the CC on as I don't think that I'm talking is working very well, so I'll try and talk through that as well. Fractional distillation is a process that uses condensation to separate crude oil into different components. Crude oil, stored in containers, is pumped into a furnace and heated to form a gas at temperatures above 500 degrees Celsius. The gas moves to the bottom of the fractional distillation column. After it is released into the column, some of the gas immediately cools and condenses into bitumen, a material used in asphalt and tar. The gas continues to rise and pass through a vent called a bubble cap. The shape of the bubble cap allows gas to pass through the top of the cap. As the gas cools, heavier molecules condense under the bubble cap and are collected. Lighter molecules still have enough energy to rise and move up to the next level. Components of the gas formed from the crude oil continue to condense at different levels. At about 340 degrees Celsius, lubricants condense. At 250 degrees, gas oil used in diesel fuel condenses. At 170 degrees, kerosene condenses. At 65 degrees, gasoline used in auto fuel condenses. Some gases do not condense at all and leave the column through the top. And so that's how they purify the different things. So if we notice, gasoline boils at the lowest boiling point, and so it condenses way up here. So it's like a backwards of a boiling. So the bitumen had the highest boiling point, and so it's going to condense first, and then go all the way in this order until you hit gasoline, which has the lowest boiling point, and so it's going to be the last to condense because it's the coolest up here and it's still hot down here. So it's still too hot for gas to be liquid down here. All right. Okay, so let's add some fractionation to our note. Okay, so I copied this from the previous slide. Fractionation, or fractional distillation, separates components of a mixture using their distinct boiling points. The solution is boiled and the vapor enters a tall tower, which is typically warm at the bottom and cool on top. Products with different boiling points condense at different levels of the tower. The compounds with higher boiling points condense at the lower levels, where it is warm, such as 340 degrees Celsius. It's important to have our units, and they're collected there. The ones with lower boiling points are collected higher in the tower where the temperature is lower, such as gasoline, which condenses at 65 degrees Celsius. Remember that the boiling point and the condensation point are exactly the same temperature. Filtering. Filtering can be used to separate the solid part of a solution from the liquid portion. If you have a heterogeneous mixture, okay, so heterogeneous means what? Not the same throughout. It might be possible to separate the solution through a process of, okay, so let's add this to our notes from the previous slide. Fractionation, or fractional distillation, separates components of a mixture using their distinct boiling points. The solution is boiled and the vapor enters a tall tower, which is typically warm at the bottom and cool on the top. Products with different boiling points condense at different levels of the tower. The components with a higher boiling points condense at lower levels, where it is warm, such as 340 degrees Celsius, and are collected there. The ones with a lower boiling point are collected higher in the tower, where the temperature is lower, such as gasoline, which condenses at 65 degrees Celsius. Remember that boiling point and condensation point are at exactly the same temperature. Okay, so it helps to think of when we're looking at this. So here is our tower. There we go. Here's our tower. Okay, it's super hot down here. So if something boils at a high temperature, it's still a gas, but then it gets 340 degrees. Well, if it was a liquid, it would turn to a gas at this point. But right now it's a gas. So because it's a gas, it's turning into a liquid and condensing at that temperature. So now it's all liquid. Keep going up, hotter, 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 hottest until you get to gasoline. Gasoline could continue to be in the gaseous phase all the way until it got cold up here at 65 degrees Celsius. Then once it got to 65 degrees Celsius, then it condensed. Filtering can be used to separate the solid part of a solution from the liquid portion. If you have a heterogeneous mixture, it might be possible to separate the solution through a process of filtering. So what does heterogeneous mean again? It means that it is not the same throughout. A cup of coffee is made in this way. The coffee filter has holes that are large enough to let the coffee solution pass into your cup, but too small for the coffee grounds to pass through. Many homes have a filter on the water pipes. This filter separates solids that may be in the water, affecting its taste or quality, and leaves them behind. The result is pure water for people to drink at home. So let's add filtering to our notes. Filtering can be used to separate the solid part of a solution from the liquid portion. A heterogeneous mixture is passed through a filter and the solution goes through, but the chunks can't. Example, coffee and coffee grounds. I should probably change that to the larger pieces. There we go. Sounds a little better. Solutions can be separated by the process of osmosis as well. You can think of osmosis as a naturally occurring type of filtration. In osmosis, a solution such as the one shown on screen is passed across a selectively permeable membrane, meaning only some things selectively can get through the membrane. Any solute is filtered out of the water. The water will move across the selectively permeable membrane from an area of high concentration of water to an area of low concentration. A selectively permeable membrane allows some particles to pass through, but leaves others behind. In other words, the purple ones have to stay on this side because they are too big to fit through the membrane. And I added to the note larger particles. I went back up to the keywords and pronunciation. Larger particles may be too big to fit through, and thus the water can be filtered. All right, solutions can be separated in several ways. As you have seen in this lesson, solutions of different types can be separated into their components in a variety of ways. Filtering, like coffee. Fractionation, okay, that was like with the petroleum, where it was all gas and then we condensed it in a tower. Chromatography, that was like with the markers. Osmosis, which is the diffusion of water. And distillation, which is boiling. Either if you have a solid and a liquid, you boil away the liquid, or you boil two different liquids, are all ways that this can be done. There are practical uses to these methods, from refining petroleum products to filtering or distilling water to produce clean drinking water. Many of these processes may seem simple, but their impact on our daily lives cannot be disputed. Mixtures can be separated by physical means. Remember, these are not chemical reactions. We are not creating something new. We're just separating. Mixtures can be separated by physical means, such as filtration, distillation, and chromatography. And that's it for this one.